Here's a really interesting thought experiment, or it could be a real experiment. You could easily do this experiment yourself. I came across this problem one day when I was playing around with some numbers and equations for probability. So here's the question. If you want to flip a coin and get 3 heads in a row, do you have a higher probability if you flip those coins individually, just over and over and over? So say you flip that coin 9 times in a row. Or do you have a better probability if you put 3 coins in a cup and then rattle the cup around and then dump the coins out on a table? And then repeat that process 2 more times, so you'll have a total of 9 flips, just like the first scenario where you flip the coins individually. So, do either one of these scenarios have a higher probability of yielding 3 heads in a row compared to the other scenario? Or do they have the same probability? What I think is interesting about this is that if you're like me, you'd say, well, of course they have the same probability. Whether you're flipping that coin individually or if you just put 3 coins in a cup and dump the coins out on a table, you're still flipping 3 heads in a row. But what's fun about this puzzle is I can show a false proof that'll make it look like you'll have a higher probability of getting 3 heads in a row if you flip those 9 coins individually compared to just putting 3 coins in a cup and then rattling it around and dumping that cup out 3 times. If you're like me, you would assume that you have the same probability of getting 3 heads in a row, whether you flip those coins individually or you put 3 coins in a cup and repeatedly dump out the cup. But I'm going to show the false proof on the next page, so you can pause the video if you want to figure this out for yourself. Here we go. I got a coin here. I'm going to flip it a whole bunch and let's see what the results are. We can get tails, and I'm going to do it individually here. So first time I flip, I get a tails, then a heads, 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 tails, heads, 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 tails. So now with these individual coin flips, let's see how many times we won and got 3 heads in a row. We got 3 heads in a row right here, head, 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 and right here, head, head, head. So individually flipping these coins, we won twice. Now what if we put these 3 coins in a cup? And I put a comma after every 3 coins because each comma here represents 1 cup of coins. So the first time I dump out the cup of 3 coins, we get tails, heads, heads. The second time we get heads, tails, heads. And the third time we get heads, heads, tails. So now we just dumped out our cup on the table and we're looking at 3 coins. How many times did we get 3 heads in a row and win? That would be 0 times, because the first time we got tails, heads, heads. The second time was heads, tails, heads. The third time was heads, heads, tails. So we never scored 3 heads in a row. I might call this a paradox because I think most people would assume you have the same probability of getting 3 heads in a row, whether you flip those coins individually or you put 3 coins in a cup and repeatedly dump out the cup. But then this proof here, which I'll call a false proof, actually makes it look like you have a higher probability of getting 3 heads in a row if you flip the coin individually instead of separating them into groups of 3. By the way, for the permutation of heads, 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 we don't have to worry about combinations, but if we were looking for something like, say, heads, heads, tails, that could also be heads, tails, heads, or tails, heads, heads. So now if we're flipping a coin individually, this would make sense. We get a head, head, tail, or a head, tail, head. But if you dump 3 coins in a cup out on a table, then how do you organize those coins so that you'll know if you're getting your heads, heads, tails on that exact permutation? And I just said right here, after you dump the coins out on a table, one option in this thought experiment is you could cover the coins up with a napkin so you can't see them, and then organize those 3 coins in a row so that way you'll have an exact permutation, for example, of heads, heads, tails. Or another option is, after you shake the coins up in the cup, you slide the cup along the table so you can dump out 1 coin at a time, and so they'll be in a row. And then that way, as you dump them out, they'll be in an exact permutation instead of just laying about randomly in some sort of combination. Here's another way to look at that false proof. If you want 3 heads in a row, which will equal a win, you just start flipping your coins, and let's just make them all heads or all winners. So here we have 9 coins or 9 heads. They're all winners. I put a comma after each potential group. So you could have head, head, head here, or starting with this comma, you could have head, 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 or starting with this comma, you could have head, head, head. So we have 9 coins, minus 2 because there's 2 heads here without a comma after it. That means we have potentially 7 winning combinations or 7 winning permutations. Now let's put our 3 coins in a cup and see what that looks like. Here we dump the cup out, we get head, head, head in the first group of 3. We do the same with the second group of 3 and get 3 heads. And we do the same with the third group of 3 and get 3 heads. So up here, if we flip the coin individually, we potentially have 7 winning combinations. But down here, it looks like we only have 3 winning combinations, or 3 winning possibilities. So now let's say we're going to do 1,000 flips, and we still want 3 heads in a row. We take our 1,000 flips here, and this means we would possibly have 998 winning combinations because we take 1,000 minus those first 2 heads there. And now we can take those 1,000 coins and we're going to put them in groups of 3 because we're going to put 3 coins in a cup and then repeatedly dump that cup out on a table. So now we have 1,000 divided by 3, which will equal approximately 333 potential winning combinations. So let's take the potentially maximum number of wins you could get by flipping these coins in groups of 3 using a plastic cup. You'll have approximately 333 potential winning combinations, and divide that by the potential number of winning combinations for flipping the coin individually, and you'll have 998. So 333 divided by 998 equals approximately 1/3. This makes it look like you have potentially 1/3 of the probability of getting 3 heads in a row if you put 3 coins in a cup and repeatedly dump out the cup. Or you could say that you are 3 times as likely to get 3 heads in a row if you were to flip these coins individually. So again, this is another false proof. I'll show more on the next page. So here, if you look at your probability tree or your flow diagram, I don't know what it's officially called. On your first flip, you could get heads or tails. Second flip would be heads or tails, and same with the third flip. So you have a 1/2 probability of getting a head on the first flip, then a 1/4 probability of getting a head on the second flip. You can add them up here. We have 1 winning permutation here of head, head out of 4. 1, 2, 3, 4. 4 possible permutations. So we have 1 out of 4 probability of getting 2 heads in a row. And then same thing with 3 heads in a row. We will have 1/8 probability because you just keep doubling your denominator. It just goes 1/2, 1/4, 1/8, 1/16, and so on. Or you could say that this heads right here is 1/2 of 1/2 of 1/2. So it's like a big pie or a big box that you're cutting up in 2 slivers. So this 1/8 probability doesn't include just triple heads, 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 heads. This 1/8 probability goes for all potential permutations, whether it's heads, heads, tails, tails, heads, tails, 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 heads, or whatever. You have a 1 out of 8 probability of landing on any permutation. So I wrote right here, all permutations equal 1/8 probability. So right here, this includes heads, 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 tails, 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 heads, heads, tails, and so on. So since all permutations will be decreased equally by putting 3 coins in a cup, then no permutations are decreased. And that's what I said right there. So yes, you do have a reduced, or at least on the surface, it appears you have a reduced probability of getting 3 heads in a row by putting 3 coins in a cup and repeatedly dumping it. But that reduction in the number of permutations is equal on all permutations. So therefore, there is no change in probability. It's like having a room with 10 men and 10 women. You would have a 1/2 probability of picking any gender at random. But then if 4 men left the room and 4 women left the room, their numbers decreased proportionally, so it doesn't change the overall probability of picking one gender over another. And here I just said a different way. If you don't want to use this flow diagram here, you could list them out like this: heads, 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 tails, which could also appear as binomial, 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on.